Hey guys, welcome to a new video in this artificial intelligence tutorial. In this video, we're going to continue talking about the fuzzy logic controller and some of the different kind of aspects that we need to know about and how we can tune a fuzzy logic controller before we can implement our own fuzzy logic controllers. And then in the end in the video, we're going to talk about FuzzyLite and how we can use FuzzyLite to implement a fuzzy logic controller in code and also in practical example. So first of all, we're just going to have a short recap here from the last video where we had this example over here with the card pole, where we had this inverted pendulum that should be balancing on top of this card here, and then we have some input force here that we can apply to the card. So we're trying to balancing the pole here on top of the card. And then when the angles get larger and when the change in angle is also getting larger, we need to apply the card down here with a bigger force in the positive or negative direction. And then we set up our fuzzy sets and our membership functions and stuff like that, and our rule base for our fuzzy logic controller. So we said that if we have two conditions or two rules that is activated at the same time, it could be, for example, the error is 0 and the change in error is 0, then we should not apply any force to 0. And then we have these two conditions here for this fuzzy set here for some given situation or for some sample. So then we have this with the and operator here. So we have these two conditions here, and then we apply these two conditions for this rule here, and then we make our alpha cut here because it is 0.25% membership degree towards 0 in this situation the system is in right now. And then our other rule down here is that if the error is 0 and the change in error is small, so the inverted pendulum here, it is 25 it is 25% 0 and then 75% to the next mole or small in the change in error direction. So our precision is still 0, it's still around 0, not 100%, but around 0. But the change in error is starting to change a bit in the positive small direction. And then when it does that, we need to apply the force in as a next small value. So we will pull the card here again to balance the inverted pendulum here up till the 0th position again. So and then we have these two rules here that are activated at the same time, and we need some different kind of methods or ways to defuzzify our inputs here. So we have these two rules here that are activated at the same time, and we make our alpha cut at the membership degree each fuzzy set describes. And then we combine both of them, and then one of the methods that we talked about was that we found the center of gravity of these two rules here that was activated, and then we could calculate the center of gravity and get a crisp value from that. So and then we converted our fuzzy logic value to a crisp value again with this defuzzifier, and then we got the value here which is the force that we need to apply to the card to be able to balance the pendulum in the given situation. And then we apply that force here again, and then some other rules will be activated, and we need to do all the stuff over again, and then calculate a new crisp value that can be applied to the card. So in this video, we're going to talk a bit about linguistic hedges, where we have these linguistic variables and membership functions, where we can hedge the membership functions in case we want to do that in some cases or for some applications where a linguistic hedge is just a modification on the membership function, so on the linguistic variable. So we're kind of changing the membership function here, and what you see they have different kind of shapes where we can have some different kind of expansive, less and very little over here, where we can see that we get a more wider shape here. So if some condition it doesn't apply that much, or it doesn't fall so fast, we can use this linguistic hedge here with the less or very little value, where we're using the square root and stuff like that. And we can also have if we have some restrictive membership function or we need to like specify something is very certain or like extremely certain. So we get like this kind of shape here as the blue and green here, where we're only like hitting 100 like 1 up here at one point, and then we're going fast down again if that condition is not true. Like if we're not up here and the input to our like universe of discourse here on the x-axis is not exactly like or close to the value here, then it will just like fall very fast. So it's when we want to like set up restricted rules, and the condition has to be like very close to that condition to like be true, or like to be partially true. So we also have some different kind of fuzzy logic controllers which we can specify in FuzzyLite, which we're going to talk about in a later video. But this is just like what we went over from the recap from the last video, where we have some two different rules that is set up here with an AND operator, and then we use this alpha cut here to like get the rule strength for each rule that is set up, and then we just combine the two like input distributions here for the rule strengths of the fuzzy controller, like, or the fuzzy sets that are now activated for a given situation. And then we have this output distribution here, where we can then use some different kind of methods to find a crisp value that we can apply to our process or system. So there are different kind of fuzzy logic controllers, where this is the Mamdani and standard like fuzzy system, and we can also like use some other type of controllers that you can go look up if you want to, like Sueno, which is a functional fuzzy system, which like we're also probably going to use a bit. And then we have like someone called Larsen and Tsukamoto in various Takamoto and some of the other different kind of hybrid fuzzy controllers. So like the probably like most used ones are Mamdani and Sueno, which we're going to focus on in this tutorial here. So we can also like tune our fuzzy controllers with some gain scaling. When we have set up our fuzzy controller and we saw like this fuzzy controller table here, where we have our input force here that we need to apply to a system for some given input, where our input was the error, like the change in like the error here, which is the angle for the inverted pendulum over here. And we also had the input here, the change in error, so like how fast is the angle changing in the inverted pendulum. And then we just set up this table here to set up a rule base so we know like which kind of force we need to apply in some given situation. And then we can have like some like in a classical control system approach, where we have like our fuzzy logic controller here, and then we have like some feedback here from the output of our inverted pendulum. So this could be like, for example, the state we're in with the angle and the change in like the angle here. So we feed back this here together with our reference. So the reference is like the value that we want to reach, and then we have our controller here, where we can apply some gain. So we can apply like just a normal like gain scale here, and we can also like apply a derivative of our gain here to our fuzzy controller, and then we can use that gain scaling to tune our fuzzy controller, which is here, which then gets then do all the process that we have talked about, and then it outputs a crisp input to the inverted pendulum here, and then the process just goes over and over again. So when we're tuning our controller, we can like do scaling on our input with some gain, and we do this input gain scaling if we want to like spread out our membership functions by a factor, or a factor. And in this case here, it's the factor of 1 divided by the gain. So in this case here, we have our like a fuzzy set and our membership like functions or degree functions set up here, where we have this like neg large, neg small, 0, plus small, and plus large. So if we want to like spread out the membership functions, so like they're more like spread out, if we want to do that in some different kind of situations, we can like just apply a gain here like this, where we just like multiply all the values down here on our universe of discord axis here. So we can see here when we apply a gain of 0.1, it's 1 divided by 0.1, so it is equal to dividing by like multiplying by 10 on all the values here on our universe of discourse. So now instead of we have like pi divided by 8, we will now have 10 pi divided by 8. So we can like scale our input gains in our FuzzyLite controller to tune it if we want to do that, or so it fits better to our application. We can also have output gain scaling. So it's not only on the input, we can also scale our output. So it's again just like we're spreading out the membership functions, but this time we're just spreading it out with a factor of h. So in this case here, we have like our membership functions here again, and we just scale them here by a number of h. So we can like spread our membership functions more like we could with the input scaling. And first, like when we're talking about like tuning our controller, we first have to like set up our controller and see how it operates with our like applications or in our process, and then after that we try to like tune the parameters here, and we try to like tune these parameters here. Like there's no like certain h or some certain input gain that we need to choose. Like it's just like kind of like trial and error and what works best, and then you just tune the parameters and you just see what works best for your application. So we can also like tune the output function here, where like we could have used like other different kind of like output functions where we tune them. So here we just have the example as in the last slide here, but then we can have some membership function here, which is just like c power to the power of I, and then it is equal to 10 I, and the I here is the linguistic numerical value here, and then down here we have like the C1, which is the sender of the membership function for I. So if we go to the next slide here, we can see like what we can do when we're like tuning our membership output function with these scales that we just talked about. So when we're just using this this function here, we can see that if we have our membership function, like membership output function like this, where we have like some points here, we just when we use this membership output function tuning here, we just spread out the membership more on the universal discourse like down here. So it could be like kind of like output gain scaling, but this is like how we like scale our membership output function. We can also use like a non-uniform scaling where like this, and it probably like looks a bit more like a normal distribution, where we have like all our points here, which is like kind of a uniform scaling or a uniform distribution. But then we can like spread out our points more, so we have like some normal distribution here, and like some of the points there getting like tighter to the center here, and then the values that is like farther away, like they're also scaled, so they will be farther away from the midpoints here. So like the most important values are in the middle here and pretty like close together compared to some of the values that are out here in the universal discourse axis. So if we have like two inputs to a system and two outputs, we can visualize it here in this three-dimensional space. And this is like how we tune our membership outputs, as we saw in the last slide. Like the first visualization is the example over here to the left, and the other visualization is the one over here to the right. So we can see that like they kind of look like each other, but like this it's more like it's more smoother in the curves, like around here, and also like just like around here. But it doesn't really make that much a difference. But we can see like some of the most important difference is like here we can see that the curve here it's like it's much steeper here compared to over here, and also like down here. So this just tells us that when the error gets bigger, or like and the change in error gets bigger, we just get a faster or like more like reacting output. So like the output value will be higher, like it will be a bigger output value quicker and also like faster. So there's some benefits by using this like by just tuning our membership output functions for our application if that's needed. So we'll have like this defuzzification here, where there's different kind of methods where we talked about like the center of gravity here, when we have two rules that are activated at the same time, but then we take the center of gravity of those two rules that are activated. But we can also like over here there's some other different kind of examples where we could have used the largest of the maximum here, or like the mean of the maximum, which is like it kind of around here, where like the center of mass, it will have been down here, and also like the smallest of the maximums, like this line here. So there's different kind of methods for defuzzification, and we can also like tune our defuzzification after we have implemented our controller. So let's say like we've tried to tune some of the other parameters, and we don't really get the one, like the output we want. Then we can go like back and also tune our defuzzificator, or not like tune them, but like change them to some other methods or like function, and see if that improves our result and output from the defuzz from the fuzzy logic controller. So just to give you an overview, or like the parameters for a fuzzy logic controller, before we're going to see an example of how we can implement a fuzzy logic controller in FuzzyLite. So we have the inputs and we have the outputs, and then we also have like this universe of discourse on the x-axis, which is like kind of our input to the fuzzy logic controller. And then we have this membership function, which just describes like how much the membership it is like in the given situation, like how much does our like membership function apply to that situation. And then we can like tune our membership functions, which we just went over on the previous slides. Then we also have like these input and output games that we can specify and play around with to get the optimal, or like the output that we want to. And then we also have to like set up our rule base here. So let's say like if obstacle is close left, then turn right fast, for example, or and then we just set up like our rule base here for the fuzzy logic controller, and we can apply that to FuzzyLite, and then it will just like set up our fuzzy logic controller. We also have like some T norms and S norms, which we're probably going to talk about a bit more about when we're going to actually implement a fuzzy logic controller, because there's some parameters that we have to set. And then we have, in the last year, we have the defuzzification. So we need to choose how we want to defuzzify our fuzzy logic value to get the crisp value here that we can apply to our process. So the last slide here, before we will see like examples of how we can use a FuzzyLite to implement a controller, where there's some like hints to design a good fuzzy logic controller. And it's not really that we need to like come up with a really complex controller to get a good system. Like it's pretty basics, and it's not like really the most complex controller there is, but it's still a really good controller to just like get into and implement fast. And it's better to just use a fuzzy logic controller than compared to like a Boolean controller, where you're just checking like if this condition is true, then if then go to the other direction, or something like that. So we need to be careful when we choose our inputs and outputs, but because we need to like choose the proper inputs and outputs. So first of all, we need to think about like what is our actual inputs to the system and like to the fuzzy controller, and what do we want to get out of the controller to apply to our system. And then we also need to like process the data into a form that fits the process. And then we also need to like think of a controller as an actual human-like controller, because like fuzzy logic is a lot like we set up our rule base, and as we talked about like with the expert that can like set up a rule base, and then we can implement that controller because it's like really human-like. Like the rule base we set out, like we say like if the obstacle is close left, then go fast right, or if the obstacle is farther away on the left side, we go like slow to the right. And then we set up our rule base of a controller like a human-like controller, so a normal human can just like also like some kind of think about like how we can control that process. And then we need to start with a simple controller, and then build off top of that if it's needed for the application. So first of all, we just start with implementing a simple controller, and then if we need more, or our output is not good enough, then we can like build on top of that controller and then tune it to our application until we get the desired output. But it's just really good to like start with a simple controller, so it doesn't get like complex and you lose the overview really fast when you're implementing this fuzzy logic controller, because there's some different kind of steps that you need to like keep track on. And if you have like a really large rule base, like you just lose the overview really fast. So let's look at some examples on like how we can design a controller in FuzzyLite. And in FuzzyLite there are two options where we can use the FuzzyLite language, which is like in a file that we just specify, FLL file, where we can just specify some variables and some outputs and inputs and some ranges, which is like the FuzzyLite language. And then we can use C++, where we like implement all of these like rules that we set up here, for example in C++, which some like it kind of looks like the same as this, but like it's just in C++, so we don't need to have a separate file that we need to import and stuff like that. So FuzzyLite here, we just have like the code over here, like, or the language here, where we have an input variable which could be like an obstacle, and then we set up like the range for obstacle here, and then we need to specify our term here. So in this case here, we're using a ramp here to specify our input variable here, and then we need to have an output variable where we want to steer some kind of like car or robot if some obstacles occur on the left or right. And then we're just set up here where we need to like specify our defuzzifier, where we're using this centered 100, which is the center of gravity. And there's also like some different kind of other like parameters, and some of them also like the default parameters, and you can like play around with them and look up the documentation on FuzzyLite's side. And then we need to specify the ramp here for our output variables as well. And then when we have like set up our outputs and inputs, and we have like logged in, like we have the ranges and we have our defuzzifiers and the terms for our controller. Then we can set up our rule block down here, where in this case here we're using the Mamdani, which is just like the standard fuzzy logic controller. And then we have our rule base down here in the bottom. Like this only has like 2 rules, so it's a really like simple fuzzy logic controller, and it's not really that good. But we can just like specify all the rules here we have in our rule base. So the first rule here is just like if the obstacle is left, then M steer is right, and if the obstacle is right, then M steer is left. So you can actually just set up like arbitrary numbers of rules down here in the rule block, and we can specify other like fuzzy logic controller methods or like fuzzy logic controllers here, and some of the different kind of functions that you can play around with. And then we can also like do our scaling and our like tuning of the fuzzy logic controller here in the language. And then when we want to like use this fuzzy logic code here, or a fuzzy logic controller in C++, we first need to include this header here, like FL headers. And then in our main function here, we need to specify the engine here, which just like takes in the file here that we have specified. And the file need to be in our directory on a computer for our project here. And then we just first check if the error is running or is not ready or something like that. Then we throw an exception, and then afterwards we need to like declare like an object here of our obstacle here, and then we set the input variable here to the engine, and we give it a name obstacle. And we do the same here for our output variable, where we create an object here called steer, and then we just set that output variable here to the engine and call it msteer. Then we run through a for loop here, where we just like specify some location that we want to go, and then we can log the log the inputs and outputs here, so we can see that here we get out the outputs here, and our inputs here, like what we give to this controller, and what we get out of the controller here in the down here. So to like get the values here from our fuzzy controller, we use this steer, and then we point to the get value function here. And this function here will return the value from the fuzzy logic controller, so like the output value to the fuzzy logic controller that we then need to apply to our system down here. So if you want to do this in C++ as well, like we can just do the same as we did on the last slide here. We've just like set up our different kind of like parameters and variables with the obstacles here. But again, in C++ we just use this object here, which from the input variable class here and the outputs, and then we just like have the object pointing to like the method here, where we can set up the name and ranges and terms, and also like down here with the terms and defuzzifier and stuff like that. So this is like how we can set it up in C++, and over here to the left, which it's the same as on the previous slide, where we can like run our FuzzyLite controller here in the code. So this is like almost the same. This is just like in C++, and we don't need to have another file where we need to like specify some other different kind of stuff. Like this, we just have this in code, and we have some objects that are pointing to different kind of methods for like setting up our controller and tooling our parameters. So yeah, that's pretty much it for this video, guys. We've been over like the fuzzy logic controller, like the last of the fuzzy logic controller, and we have seen like different kind of ways we can use fuzzy logic controllers, and also like how we can implement a fuzzy logic controller in C++ with this FuzzyLite library. So thank you guys for watching this video, and remember to hit the subscribe button and bell notification under the video, and also like this video if you like the content and you want more of it in the future. I'm currently also doing this computer vision tutorial in C++ or algorithms and data structures. So if you're interested in one of those, I'll link to one of them up here, or else I'll just see you in the next video, guys. Bye for now.